Why should you learn about molecules? A nanometer is 10 to the power of -9 meters. In future, nano-sized materials such as the C60 molecule, also called Buckminster fullerene, are going to make a revolution in the field of molecular electronics. Do you know what the smallest molecule in the world is? It is the hydrogen molecule. The concept of the molecule was introduced by Amadeo Avogadro in 1811. It was accepted based on Dalton's law of definite and multiple proportions. Let's explore how the molecule appears. We have seen kids playing with soap bubbles. What happens when two soap bubbles fuse together? They form a dumbbell shape as shown in the visual. Similarly, when two hydrogen atoms fuse, they form a hydrogen molecule. The number of atoms constituting a molecule is called its atomicity. Hydrogen is a diatomic molecule, that is, it has 2 atoms. Other examples of diatomic molecules are nitrogen, oxygen, chlorine, etc. A molecule of an element consists of atoms all of the same type. Ozone has a triatomic molecule. It contains 3 atoms of oxygen. The sulfur molecule has 8 sulfur atoms. It is represented as S8. The combining capacity of atoms among themselves decides the atomicity. The atomicity of sulfur in the sulfur molecule is 8. A molecule of a compound is made up of different types of atoms or elements. For example, a water molecule has 1 oxygen and 2 hydrogen atoms. Similarly, a carbon dioxide molecule contains 1 carbon and 2 oxygen atoms. Ammonia has 1 nitrogen and 3 hydrogen atoms. A sulfuric acid molecule has 2 hydrogen, 1 sulfur, and 4 oxygen atoms. How do we arrive at the ratio of hydrogen to oxygen as 2:1 in a water molecule? Look at this table. Hydrogen has the mass 1 and oxygen has the mass 8 in water. The atomic masses of hydrogen and oxygen are 1 and 16. When these masses are divided by their respective atomic masses and converted into whole numbers by multiplying by 2, we get the simplest ratio. Now we can derive the ratio for hydrogen and oxygen as 2:1, and hence the molecular formula for water is represented as H2O. A charged particle is called an ion. Ions are classified into cations and anions. Cations are positively charged. Hydrogen has 1 electron and 1 proton. If it loses 1 electron, it becomes H+ cation. Anions are negatively charged. Chlorine can accept 1 electron to become a chloride anion. Cations can further be classified as monovalent, divalent, and polyvalent. Sodium loses 1 electron to become a sodium cation. Similarly, calcium loses 2 electrons to become a calcium cation. Iron loses 3 electrons to become an iron 3 cation. It is also called a ferric ion. Cations can also be classified as monoatomic and polyatomic. A polyatomic cation consists of more than one atom. Anions can further be classified as monovalent, divalent, and polyvalent cations. Chlorine withdraws 1 electron to become a chloride ion. Similarly, oxygen withdraws 2 electrons to become an oxide ion. Nitrogen withdraws 3 electrons to become a nitride ion. The atomic mass of hydrogen is 1. Then, what is the molecular mass of hydrogen? Is it 2 because it is diatomic? Yes, the molar mass of hydrogen is just double the atomic mass of hydrogen. Molar mass is the sum of the atomic masses of all the atoms in a molecule of the substance. For example, the molecular mass of water is calculated as shown here. The letter U represents atomic mass unit. Formula mass is the sum of the atomic masses of all atoms in a formula unit of a compound. This is almost similar to molecular mass. We use the term formula unit for those substances whose constituent particles are ions.